All right, this movie is for Unit 6, Learning Target 11, Applying Coordinates in Geometry. A warm-up here is the points are 3 vertices of a parallelogram. What are the possible places for a 4th vertice? So if I'm doing a parallelogram here, you can see that I could have a point down here. I could have another point. There's 3 different situations. I could have one at 8, 6. I could have a point up here, making a parallelogram. I could have one at 6, 0, making this parallelogram. I could have one here at negative 4, 4, making this parallelogram. So the fact of the matter is, as far as location goes for different points, it could vary depending on the 3 that you're given. Because of that, we're going to use variables for points in the next few slides. So we can use, our essential understanding here is that we can use variables to name the coordinates of a figure. This allows you to show that relationships are true for a general case. Just like in algebra, when you know something is true using specific numbers, you can state that it's true for all numbers by using variables in the general case. Let's study this scenario here. In our Unit 5, we learned about segments joining the midpoints of 2 sides of a triangle. Here are 3 possible ways to place a triangle and its midsegment. So if we place it out here, point P will be located at a random place to the right and a random place up. So it'd be at A, B, let's say. For R, I went out not A distance, but E distance, and up the same as I did for P, so they both would have a Y coordinate of B. Q would be somewhere in between here. We could call that C, D. However, if I'm more strategic with the placement on a coordinate plane and I put point P at 0, 0, that will limit, I'll have fewer variables to deal with. So if PP is at 0, 0, I didn't mean to say PP, if point P is at 0, 0, then point R will be C units to the right and 0 units up and down. Q will be at AB. Now, I could even be more strategic over here and say that I go negative 2A distance this way and 0, and I go 2C distance this way, 0, and Q would be up, so it would be 0, 2B distance. Now the reason for that is because I know MN is a midsegment, and so it's going to be twice this length. So figure 1 does not use the axes, so it requires more variables, but figures 2 and 3 have good placement. Figure 2, the midpoint coordinates M are A over 2 and B over 2. And N is at A plus C over 2 and B over 2. Now in figure 3, the coordinates are M is at negative AB and N is at CB. So because these look so unusual, we still know that M is going to have easier coordinates to deal with because of what I've made the other points. It's usually helpful to place at least one side of a figure on an axis like we did before, or center the figure at the origin. For the coordinates, try to anticipate what you will need to do in the problem. Then multiply the coordinates by the appropriate number to make your work easier. Let's see how that's related to the polygons we've been dealing with. What are the coordinates of the vertices for each figure? SQRE is a square, where SQ is equal to 2A. So we know this distance here is equal to 2 times A, 2A. So that tells me that that is a distance of A, and this is a distance of A. Because of that, I actually know that that's true down here. Oops. So I know that for making my ordered pairs, I know that SQRE is a square centered at the origin. So if I go A to the right and up A, point Q is going to be located at AA. If from the origin I go A to the left, which is negative A, and then up A, S will be at negative AA. If I go negative A, down A, E is at negative A, negative A. And if I go A, down A, I get A, negative A. TRI is an isosceles triangle where TI is equal to 2A and the y-axis is a median. So knowing that this y-axis is a median, I've got two congruent triangles here. The y-axis is a median, so TI is bisected by the y-axis. So if TI is 2A, then I know that I go out a distance of A to get to I, and I don't go up or down, so it's A0. And I go to the left A, and I don't go up or down, so it's 0. T is at negative A0. Now, as far as R, we do not know the height of R, so I introduce another variable, B. So I neither go left or right, so it's 0, but I go up a distance of B. So I get 0B. What are the coordinates of the vertices for each figure? Rectangle is here. A rectangle's height of A. So we'll put A. So it's got a height of A, and it's got a length of 2B here. The y-axis bisects EC and RT. So I want you to pause the movie, try this one on your own, and press play when you're finished. All right, you can see that with a length here of 2B, to get to T, I go to the left or to the right B units, because as if I have B here, a B there, and a B here. So because of that, I went B units to the right and 0 units up or down. So point T is going to be at B0. C is going to be, I go out B and up A. So C is at BA. R, I go to the left B, so it's negative B, and I don't go up or down, so it's 0. So R is at negative B0. And E is I go to the left B, and then I go up A. So E is going to be at negative BA. So here are the points that you would get using variables so that you could talk about the general case. Looking at kite, where IE is 2A and KO is B and OT is C, the x-axis bisects IE. I want you to pause the movie and write down what the coordinates of each of this figure would be. Now this you're going to input as one of the questions at the end. All right. Next problem. The whole point of this is that we can use variables to then verify things on the coordinate plane. This diagram shows general parallelogram with a vertex at the origin and one side along the x-axis. What are the coordinates of D? So it's the intersection of the diagonals, and we want to know the coordinates of it using these variables. So we know the coordinates of the vertices of parallelogram ABC, O. We know OB bisects AC. OB bisects AC, and AC bisects OB because it's parallelogram. We need the coordinates of D, and since the diagonals of a parallelogram bisect each other, the midpoints of each segment is the point of intersection. So we'll use the midpoint formula on this. So we add the x's and divide by 2, add the y's, divide by 2. So if we're looking at the midpoint of AC, and I add 2b plus 2a divided by 2, I simplify by reducing by 2, factoring out a 2 and reducing it, I get a plus b. If I do 0 plus 2c divided by 2, I get 2c divided by 2, which is c. So the midpoint ends up being a plus b, comma, c. That's going to be the end of this movie. Answer the question, and that is the end of this learning target.